In the last decade, the global mining industry has stagnated. Commodity prices have been falling constantly due to lower global demand, excess capacities, and the appearance of new substitutes. Hence, margins have narrowed, affecting cash flows. It is important to highlight that mining is a cash-intensive industry, and thus it needs high margins to be sustainable. Existing mines are maturing, which means that more efforts need to be done to extract the same volumes. On top of that, new mines are in remote and distant places, resulting in higher investments and costs. On the other hand, the industry has not evolved significantly in terms of automation, processes, or ways of doing things, ending in lower productivity rates. According to McKinsey, worldwide mining operations are as much as 28% less productive today than a decade ago. Besides, workforce is aging, assets' lifetime have already been extended, and costs have already been reduced. It seems that there is nothing left to bring the industry back to its golden years. Therefore, the mining industry needs to be rethinked, disrupted, and maybe reinvented. That is why big corporations are looking at digital technologies, trying to find new business models and new ways to interact, having the cost reduction as the main driver.
Technology will assist the mining industry mainly in reducing costs throughout its value chain. Many aspects of the supply chain can be affected by technology. Today, we will only focus on operation management and equipment maintenance. Indeed, as per McKinsey prediction, 95% of the savings due to technology will be originated from those two elements of the value chain. Operation management will be supported by the full set of technology mentioned earlier on. Mining operation is extremely human resource demanding and poorly automated, and until recently, automation systems have been very expensive and fragile. With improvements, however, modern automation is much more affordable and effective. Technology can reduce human intervention, both in physical human work as well as in process control. First, drones will be connected to an automated AI-backed central control platform that will monitor the whole mining supply chain in real time. All industrial machines will be connected to the system and processes will be fully automated. The system will optimize the flows of material and equipment, increasing operation efficiency. Still, human resources will be required, but their efficiency will be increased with enhanced human-machine interfaces, such as mobility systems linked to virtual reality. An example is the ability to command a machine remotely in a secure environment that could be located in an hazardous area for humans. Equipment maintenance will mainly be supported by industrial IoTs and analytics. Indeed, all industrial machines will be connected and data will flow on cloud platforms where analytics will be performed. Analyses are performed using historic data located in the cloud, big data, and AI systems. This predictive maintenance will increase machine efficiency by avoiding spurious breakdowns, by reducing costs for not doing unnecessary maintenance, and that will be resulting in a longer machine life. Thus, instead of carrying out preventive maintenance that can be unnecessary in some instances or too late in other cases, for example when equipment breaks down, maintenance is predicted based on machine behavior.
In terms of technical measures, the business needs to establish clear performance measures to allow for ongoing monitoring of progress against objectives. These performance measures need to be reviewed with internal stakeholders. The performance measures for this project fall into three categories. 1. Management of project budget, schedule, and scope. 2. Alignment of project against project goals. And 3. Internal customer satisfaction. In terms of management of project budget, schedule, and scope, we would measure 1. Budget, spend against budgeted, 2. Schedule, tasks or milestones completed against plan, and 3. Scope, avoidance of scope creep. For alignment of project against goals, we'd measure increased mechanization through automation of mining equipment, reduce operating costs, improved operating discipline, and reduce workers' accident rate. In addition, we'd measure reduced number of employees working in the mines, particularly in harsh environments, improve management decisions, making through better use of analytics and intelligence, use of real-time data and maximize utilization of equipment and yields, improved ore grade, reduce gaps in processes to improve operational and cost efficiencies, and reduced operational disruptions. For customer satisfaction, the measurements are technology availability, uptime versus downtime, technology functionality to meet the end user's needs, and technology adoption rate. For organizational measures, recent studies suggest that the mining industry is slow to adopt digital transformation due to budget constraints from falling commodity prices. Therefore, such transformation requires the effort of the CEO to shift and articulate the company's vision, strategy, and operating model in order to set clear direction and expectation for managers and employees. The company also needs cross-functional teams that understand how to integrate mining operations with technologies to change processes and the way people work. The management can help adapt the organization by creating clear ownership and objectives to hold people accountable. Finally, the company needs to train current workforce and engage tomorrow's digital workforce to ensure that there's no shortage of skills required to meet the current and future needs of the organization. So how is the industry changing due to technology transformation, and what are the drivers? The first important point to understand is that mining companies have a low level of digital utilization due to challenges including geographic spread of operations, large differences in equipment and existing technologies, especially because of multiple acquisitions, managerial conservatism, and complexity of operations. But mining is similar to other industries in that digital transformation is accelerating and is both cause and consequence of larger trends. These trends include 1. Global demand, 2. Changes in industry fundamentals, 3. Challenges in the workforce, and finally 4. Government and society. For global demand, mining companies face lower demand for their product due to multiple factors. Digital transformation and new business models are intensifying the trend. For example, the sharing economy, including car-sharing apps like Uber, which reduce the need for autos, improve supply chain efficiencies, and the circular economy, which emphasizes reuse recycle initiatives rather than extraction. Technology in turn allows companies to respond to these challenges. Companies that can gain efficiencies via robotics, intelligent deployment of sensors and machine learning, and data sharing can win market share. Second, industry fundamentals. There are two key changes affecting the underlying fundamentals of the industry. First, resource scarcity. The low-hanging fruits have been picked. On existing sites, remaining ores are lower grade or harder to reach. New sites are remote, difficult, or dangerous locations. In addition, companies face heavy competition. Excess capacity was built up in mining in the boom years. Much of this capacity stays online. Digital transformation could exacerbate this trend, as it allows some weak players to hang on for longer. However, if industry leaders emerge and quickly differentiate themselves on cost against competitors, this could allow them to outprice the weaker players. Digital will also have significant impacts on miner workforces. Mining companies face an aging workforce who are less comfortable with digital technologies. New hires, by contrast, lack a deep understanding of mechanical operations. Thus, companies are facing a skills gap to operate mines with new technologies. Mining companies are also interested to reduce the costs due to the workforce by finding alternatives to human labor. This includes robotics, automated heavy machinery, and especially digital tools and analytics that allow managers to employ human resources more effectively. Finally, technology plays a critical role in ensuring worker safety, especially as miners travel to more dangerous places. Connected sensors, monitors, and alarms are important tools for reporting and avoiding events. And finally, social and regulatory trends affect miners. These include resource nationalism, as well as local awareness of the environmental and economic and social impact of mining. In addition, there's increased regulation. Companies are facing toughening regulation, including environmental and corruption regulation. Digital technologies will accelerate this trend by allowing continuous monitoring and visibility of environmental and social impacts. It will also give companies the capability to manage the risks and improve the capability of companies to report and engage with stakeholders. The digital transformation on mining will affect society in three ways. First, workplace safety. The digital transformation will make mines safer for workers. In addition, it will help to reduce workers to the most dangerous activities, for instance, drones replacing the need for geologists to go on site. But also the digital transformation will reduce jobs and therefore reduce employment in local communities. The second way the digital transformation will affect society is through safer local communities, through better monitoring. And finally, the digital transformation will help to reduce CO2 emissions and indeed make our planet great again.